Dots. No hope.
Okay.
I should have won mine.
We should begin.
Okay, great. Okay, with a slight delay, to increase the excitement and tension, I can welcome you to the second session of FUNARCH'. It's good to have you all here. The room is packed, which is mostly a property of the room, but it's still great to have you all here. Our next speaker is Ben, who told me that most important to know about him is that he goes by Ben and not by David. So even though the name tags are something else, but at least you don't have Microsoft as a name tag, so that's
right.
Better than some people. Bogdan, his co-author, is in Romania. I don't know if he's listening, but thanks for your work. And I heard there are some board games in the talk, which I think makes the talk already one of the best ones in the whole week. So go ahead.
Thanks. So yeah, the audience got a little bit of a preview. We're going to talk about functional shell, reusable components, easier GUIs, and just a skosh of Frosthaven. So I'll dive right in. We like to build small GUI tools, or at least I have discovered that I enjoy this now. And we're going to do this with Racket. So if you're not familiar, Racket's a Lisp. It specializes in language-oriented programming. It's got one of the best macro facilities out there at all, but also has lots of other batteries included. And the typical solution with most languages, but especially with Racket, is the object-oriented toolkit. And I want to stop and say there's a lot of really good things in there. It's cross-platform. It has a wonderful plethora of widgets. It's actually used to build the Dr. Racket IDE, which is a phenomenal both teaching and professional tool. But there are some downsides. Working with this toolkit, we have lots of classes, and our code is not really organized in the same way as our application is. We have to do a lot of state synchronization between our application and the things we want to display on the screen. And in general, we struggle with composition, reuse, abstraction, all the things we were talking about this morning with Michael. And it's a bit daunting. So it really feels like you need expertise in the widget library to start. You got to know not just what a button does, but what a canvas is and a drawing context and all of these pieces. So we found that experts like Bogdan, but also complete novices like myself, struggle to write large programs with these toolkits. So we're not so happy. But on the flip side, working with GUI Easy, Bogdan's library has been a joy. Our GUI containers are going to programmatically contain their children, so we'll see some examples of what that means in a moment, but that sort of solves our organizational problem. We get these automatic updates via observables, which sounds like one of the Gang of Four patterns and is somewhat related. So that solves our state synchronization problem, and we get composable functions that actually represent our graphical applications. So all the good functional programming stuff that we know and love, we have functions, so we get to do all of those things. And then because it's got such a small core and it's easy to extend, you don't have to have quite so much expertise in the library of widgets. But for those that need those expert capabilities or that want to tap back into the expert system, there's some escape hatches that kind of bring you back down a level, and I'll talk about those towards the end. So the sort of high-level version is GUI Easy is much easier to learn. It's also been a gateway to the object-oriented toolkit. So I've actually started using the object toolkit more because I'm using GUI Easy in my projects. So we're much happier with our solution, which really revolves around these two fundamental concepts of views and observables. Before I cover too many of the details, I want to do a small example, and by small, this is our goal, right? So this is where the board games come in. Frosthaven has area of effects, and it's important, especially when you're talking about what the monsters are doing or what the characters are doing, to really be able to describe those pictorially. For the game, we put in lots of data about how these things work. So on the left, we're going to have an editor. We're going to type some textual representation of that area of effect. And on the right, we want to get a live picture, some feedback on what that's going to look like when we render it in the game. This is, and it's very dense, so just bear with me. This is typical object-oriented Racket code for the kind of editor that we want to build. But I'm going to walk you through the key components. This is all of the main functionality of that application. Okay. This bottom bit down here is drawing the picture with a little bit of error handling. We have some style on our editor. We have our state for our editor input at the very top, and we have just a label for the window so that we know what we're dealing with. We have a little bit of input synchronization, and we have to be careful that we get the editor input and refresh our canvas so that we draw an updated picture. Otherwise, our picture is stale. And then the rest is pretty well boilerplate. We have names for variables that we never use. We have to construct these widgets with references to parents, which sort of is going to tie back into our organizational problems. And as a whole, the picture is sort of scattered about. We have the functionality, but we also have all this other cruft. But it works, and so here's, if it will animate. So you can type, and you get these nice pictures, and that's roughly what they look like on the cards in Frosthaven. So it works, but we think we can do better. And in particular, we think we can make it easier to write these sorts of small utilities. So here's the GUI easy code. We want to render something to the screen, so we're just going to start with a function call, render. What are we going to render? It's going to be a window. Okay, it has a title. We need to do a little geometry management, just like in the previous version. So we want to have something on the left, something on the right. That's going to be a horizontal panel. And the first child of our horizontal panel is the input widget. So this is how we get textual input. And we need some state at the very top. That'll be our input. And then when the input changes, we'll update our input to say, hey, there's been some user input. Our other child, though, is a picture canvas. And all it knows how to do is draw a picture in response to some data changing. That data is going to be our input state. And when it changes, we'll apply this function to produce a picture and automatically draw it. That's the whole code. Much less dense, or much less boilerplate, far denser in concepts. We have exactly what we need, but you're also seeing the sort of functional style of constructing things. And this works exactly the same. I've embedded it in the slides here, so we can type, a picture out, and it works, right? It works just the same, with the major difference being the code, the organization, the architecture of how we build the system. Any questions so far? Stop me if you get lost. So I said the primary concepts are views and observables. Let's talk about observables first, because that's what we saw when we talked about state management and reactive updates. Observables are values. We have a constructor. We typically use the @sigil here for that. And we have a couple of major operations. We can set the observable from some value v to some expression e. We'll evaluate it and get a new value in. And any listeners that are waiting for changes to the observable are going to get notified that that value has changed. We can also update observables by applying functions. So a more typical version is that with our left arrow here, we're going to have, instead of @v, we'll have @f of v. In the other direction, we're going to map observables into new observables. So the left arrow is a state change, and the right arrow is produce me a new observable in a different domain that changes whenever v changes, but the observable's value is f of v instead of v. And then at the slightly lower level, we can extract v out of the observable, and we can subscribe to events on that observable when that's useful. Views, however, take care of most of the subscription details for us. Views are functions, and in Racket syntax, this means that they return an instance of the view interface, but we'll talk about that a little later. In particular, though, views are observable aware. So we take in our dependencies, like some data and how to turn that data into a picture, and views will react to changes in those dependencies. Views are also composable functions. So we saw the hPanel example earlier. These children are going to be themselves views, and we're going to compose that into a larger view, and we can sort of take that to the extreme. Here's a very simple example out of things like 7 GUI. We have a counter. We have a window that has 2 buttons and some text, and the counter operates, just to show you. The way we're doing this is the 2 buttons have callbacks attached that say subtract 1 or add 1 from the value. And then the really interesting bit is the text widget in the middle that actually displays the counter value. The counter value is a number, but we're able to map that into a string, and our text widget updates with the string value whenever our buttons update the actual count state. Any questions about this example? Because we're going to take it apart in a minute. Cool. So, like I said, we're going to take it apart. We're going to abstract a little. We can take that H panel with its couple of buttons and some text, and we can call that a counter view, right? We can turn it into a function because, after all, views are functions. We need some dependencies. We need to know what the count is. And we're actually going to turn that direct update into a callback, and we're going to call it action here. And that gives us the ability to render multiple independent counters and have reusable abstractions. I'll spend some more time talking about this action callback and why it's important. The idea here is to reduce coupling and to really give us the flexibility to decide when I create a counter view, how should it react to user input? It's going to tell me that users have clicked buttons or done some other action, and I get to decide as the constructor of counters what happens. I don't have to have counter make that decision for me. So that gives me flexibility, and it also reduces the coupling between a counter must behave in a specific way and gives me more flexibility about what that actually means.
So at this point, how would you describe in your manual or API this counter abstraction?
So, and that's a good question, because the project that I have been working on for the last little while has its own library of domain-specific abstractions and their documentation. So a description for something like this counter might say, inputs are a count variable, which needs to be an observable of an integer, or some kind of number, and an action callback. I would tell you that action callback is going to be called with one of two values, right? In a typed language, you might have an enumeration for those kinds of values, and I'd say you're either going to get a procedure like subtract one or a procedure like add one, which takes a number, turns it into another number, and it's up to you to decide what to do with that procedure. In our case down here, we're actually updating the counter variables. So we're saying that when we get a procedure like add one or subtract one, we're going to update the corresponding counter variable by applying that procedure to it. So we haven't functionally changed our actual example, but you could imagine doing something different. In fact, if you swapped these two counters, then the buttons would operate on the other counter, right? So you have that flexibility. Does that help answer the question? Okay. The important piece here is that we're able to create domain-specific concepts from the lower-level graphical concepts like buttons. There's some relationship here, I think, somewhat obviously to the model view controller frameworks. In particular, we have some state, it's a model, and we have some views, they are views. And then the most nuanced piece, the controller, and how these callbacks work. As I said, they give us flexibility. One of the major criticisms of MVC frameworks for the last several decades, I think, is that controllers and views tend to be very tightly coupled. And here we're sort of loosening that by a large margin and saying that we should pass data around and not force you into a specific way of acting. The style of application that this tends to look like, we're going to have observable state at the top levels of our abstractions, and we're going to feed bits and pieces of that down to the child and leave components that are really responsible for ultimate display. But we're going to have our controller callbacks react to user input at the leaves and feed that back up to the top level to really decide how to make decisions. This came a little bit out of the Elixir community, which I think popularized the phrase data down, actions up. And so that's what we're seeing here. We have observable data that comes down the application and actions that come up the application. I also like to think of reusable components as being somewhat isomorphic to pure functions. We take in data, we take in all the data we need, we take in the callbacks that we need, and we don't interact with the outside world. We don't directly mutate our inputs. Instead, we delegate that responsibility to the top of the application that knows how to mutate appropriately. That would be kind of a functional core imperative shell. There are some other details in the paper. We talk about the object lifecycle and how the view interface and render objects really make this more of a framework than just a toolkit. The central concept there is inversion control. GUI Easy manages the details of what a graphical application lifecycle is like, and your job is put the boxes together, put the puzzle pieces together. One of my favorite bits is that we talk about black box versus white box frameworks, and so in this discussion, a white box framework is very transparent, so you need to know all the details in order to be able to put the pieces together. Whereas a black box framework hides a lot of details from you, but the trade-off there is that those pieces are much easier to put together and glue together. In that framework, we like to think of Racket's GUI framework as being white box, being very object-oriented, and GUI Easy being more black box. But we have these escape hatches. You can create custom views, and you can use Racket's mix-ins to tap back into that expert system level and get the functionality you need. We use this to great effect in Frosthaven and in other projects. There's a plethora of related work that we talk about in the paper, other GUI toolkits, but also you might be thinking of React.js and other reactive web frameworks, the functional reactive programming community that's been looking at ideas like this for many years, and there are definitely some correlation here. I think what's somewhat unique about our work is the packaging and the way we're applying this directly to graphical systems and giving you control over the full stack. Conclusion, I just want to wrap up, and then if we have time for some extra bits, I'll go through them. GUIs with objects tends to be a little more difficult. It's more of an expert system. GUIs with observables and functions, it's easier. We get all the benefits out of functional programming that we're excited about for functional programming, like purity, composition, abstraction, reuse. And we started asking ourselves, what other imperative or object-based systems deserve this FP facelift, this veneer of functional programming on top of it that allow us to get these benefits from imperative systems. So that's what I have. I have plenty of extras to dive a little more deeply into some details if people are interested, but that's it for me.
Thanks, that was great. We have good time for questions, and I see the first hands are raised, so yeah, I guess I'll just...
Thank you. Hi, Will Creighton from Brown. Can you go back to a slide that contains one of the code snippets on it?
Certainly. Well, let's do one of the counters. That's a simpler example. So this was one of the early counters.
Okay, so a really critical thing in stuff like React.js, when you use frameworks like MobX or Solid.js, is you need to localize state in the sense of, if I change one piece of state in a tiny part of my GUI, I do not want everything to re-render.
Right.
Or even if I'm using some kind of shadow DOM, I don't want all of that code to get invoked and then do a bunch of useless comparisons. And it's not obvious to me here, just looking at this, if I change count, how do I only know that the text should update as opposed to everything else, without doing some kind of dependency analysis that presumably is not exposed at the sort of library level. So is there any consideration for that performance issue, or how you would deal with that in this style of framework?
Yeah, so let me just rephrase and make sure I understood. I think the central question is, right, what's the level of dependency analysis here that helps us with performance trade-offs, like re-rendering the whole tree of the application versus just the subcomponent? Is that right? Okay. So this is where I'm going to go back to views are functions, and especially views are mostly pure functions. They create a representation of the graphical object, which means that the rest of this tree doesn't even know that text depends on count, at least in this presentation of the code. So hPanel and button have no idea about count, except that there's, I'm glad I brought the extras. The way this really works is that our representation tells containers about dependencies, and containers forward updates down to widgets. But my widget has to selectively say, I'm interested in this dependency, and when it changes, I need to make X change. So the picked canvas doesn't even listen for updates to the counter or whatever other variables are involved. So they're not making any changes, but it's a decision that's made based on, here's the dependency that's changed, and you decide as a view, is that something that you're interested in or not?
Sorry, how does picked canvas know not to listen to those updates?
Well, picked canvas isn't even, so let me go back to the picked canvas example, which is here. Picked canvas, well, that's a bad example. Okay. So
But I'm interested in this example, though.
yeah, so in this case, right, picked canvas is interested in input,
Okay.
so it must know that that input is a dependency. So when you construct a picked canvas, you're giving it the input observable, and it says, okay, that's an observable.
Yeah.
I must be interested in its changes.
Yeah.
But in the counter example here, right, button has no knowledge of the count variable, so it can't even express an interest in that dependency.
But how? But like text, I assume the implementation of the text widget cannot introspect the expression on the right and know that it refers to @count.
Correct.
So how
It's
does
it's an anonymous observable in that sense. There's
I'll move on. I'll let someone else ask a question. But I think there's
let's
details
talk
here I'm
later.
curious
I
about.
think Bogdan has a better answer for you than I do.
Okay, thanks.
So I, once upon a time, wrote some very simple graphical things using Big Bang, which is the Racket kind of event loop for students. And I'm trying to think how I would talk about the architecture of GUI versus the architecture of Big Bang versus the architecture of the object-oriented toolkit. And this, if I put on sort of my simple-minded hat, I'm looking at GUIs, oh, this is a nice compositional way to write Big Bang functions. But I don't know if that's a good way to think about it. So could you say a little bit about how would you describe I don't know how well you know, you might not know Big Bang, which is okay, but how would you describe how these things are put together? What is the architecture of the system? How do they think about functions? How do they think about objects or not objects?
So the good news is we have a Racket expert in the room. I'm not as familiar with Big Bang, but my understanding with Big Bang is that it's a lot like our state machines that we were looking at earlier, right? We have a state and some functions that manipulate it and know how to draw pictures, right? And it's pure function state to state to state to state.
Yeah, I think it's pretty much one function. This is, the stuff comes in, you draw it, and you sit around and wait for the next.
Yeah. So, and I talk about this some in the paper. With GUI Easy, the way to really think about it is we have taken an imperative system, Racket's object-oriented toolkit, and put a functional shell over top of that. But when you're organizing a graphical application, we're still going to use a somewhat imperative shell functional core model. So the core of my 10,000 lines of Frosthaven application is a bunch of data structures, enumerations, algebraic data types, things like that, and transformation functions that map from one to another. The GUI part then wraps that up in graphical state and says, when there's a command, a user input, that needs to make a change to the state, I'm going to apply one of those transformation functions to my state and get a new state. And as a consequence, all of the things that are depending on that state for rendering are going to update automatically.
And how would you describe that's different from what you would have done if you programmed with the Racket GUI toolkit directly?
With the Racket GUI toolkit, and Matthew, forgive me if I'm wrong, that state synchronization in particular is fairly manual. So I'll go back to the original code here. Right, here's the synchronization of we've had to make this change in our input, but we're not automatically deriving the fact that our canvas needs to update in addition. So we have to manually keep track of the fact that our canvas depends on that editor input and refresh it ourselves.
And that callback looks like it can be anything. So the notion of updating in response to change,
So the callback looks like it could be anything. So the notion that I depend on this input and need to update when it's changed, that notion's been lost here.
Right. The terminology that we use in the paper is that this is ad hoc state management.
Yeah, I kind of want to follow up on that. So in practice, is it the case that you have like one observable that contains the application state, and then you kind of compose functions on it that extract parts of it?
Yeah. So it might be a large record.
Yeah.
my largest application actually uses a record of small observables, which I'm still trying to decide if that was the right design choice or not. An observable of a record versus a record of observables.
Well, the question is, I mean, what you have not shown is that if observables compose, right? And I think they don't.
So they do a little bit. You can combine multiple observables into a single observable.
Okay.
This map function, I've presented it as a sort of a single arity, but there's a variable arity version that says take this function f and apply it to multiple observables to create a new derived observable.
And
it's just not shown here.
okay. And and can you set that resulting observable?
No, any derived observable is
and so
is
that
effectively
I would
immutable.
suggest is the crucial aspect here, right? This reminds me a lot of the early sort of closure-based wrappers around React, right? So React started out as having that notion of component state that you would imperatively set. Similarly, I mean, unfortunately, the component state was really tied to the component, so you separated out that notion. I think that's a good idea.
Here we get both. So you can have local component state when you need it, and sometimes that's valuable. But for the most part, you have top.
But what I mean is you've separated out the abstraction for the observable, right?
Yes.
Whereas you always have to provide the component with React, right?
Right.
React has since moved away from that pretty much. So to the point, I think, where it's an anti-pattern, where they really only have essentially immutable application states sort of flowing down into the component tree. The trick with that, to get back to Norman's idea, I mean, the thing with the difference between Big Bang, where you're doing a video game, and this, is that Big Bang, in a sense, is monolithic, right? It's called Big Bang. So, and the trick with that is to get it to be modular, right? I mean, you can split that up, right? But that is actually it's not so easy. So we've worked quite a bit on a web toolkit based on React, which has gone through 3 iterations now. I think the last one is pretty good, but the problem is you have an application, right? You have an observable sitting at the top, and you want composition to extend to that. Right? When you have now 2 applications and you want to compose those, right? You already have your observables in place, which tend to be at the top level, right? And how do you kind of have that percolate down? So it's possible, but it requires more machinery, and that I think this sets a pretty sweet spot in being very easy, especially for smaller applications.
That's definitely our impression as well, and I'll just highlight that a majority of the application state that flows through at the bottom level, you don't know if it's immutable or immutable, so you need to treat it like it's immutable. That's why we have these actions that come back up. And then, as I said earlier, right, this notion of extracting domain-specific functions that represent domain graphics certainly ties into a module system.
Yeah, but that's exactly the issue, is that your actions typically flow up all the way to the top, right? And so somebody has to know about all the actions in your application. And if you have really complex APIs, you really want to build components where every component only knows about it, has its own actions.
Yes.
And you can isolate that from the other ones.
I guess I have also a question. So I've played around with functional reactive programming, and this seems to be a bit more imperative than you're taking it. Okay, sorry. And I wonder if there are things where you think that, like this idiom, where you can shoot in your foot more easily than you wish. Like, for example, can you, maybe more concretely, is it the case that you can subscribe to an observable and in the subscription update other observables? And if so, can you accidentally or like start things where it just keeps updating itself in circles, and you have to deal with that?
I haven't tried to, but I think the answer is yes. The subscriptions are effectively arbitrary callbacks. So here's the new value, do with it what you want. Yes, I think the answer is there are some foot guns, and in particular, like we were just discussing with mutability, trying to update a derived observable is a runtime error.
Okay, but it's not something you ran into, like, while you were using it.
In practice, and this is actually a feature that I wanted to talk about if we had time. So in practice, I haven't had to use the subscription API except for one case. So on the left, you're seeing the application for our board game, and on the right, you're seeing a web browser view of that application that is run as a server locally by the GUI, and updates in reaction to the GUI updating. And when you interact with the web server, it updates the GUI back and forth. And that's the only time I've had to use the subscription API because I needed to teach the web server how to react to changes in the GUI. But that one very delimited case is take the new values and send them over to the web server side of things.
Okay. Any other?
So I think that's often since the original FRP paper came out, it's often been an intuition that we should structure UI toolkits like that. But the thing is that FRP solves the problem of how to compose over time, but what you really want to compose is the values that change over time, right? And FRP doesn't have a solution to that, and that's the bigger problem, right? And that's also why I think Elm originally started out as sort of FRP based, and they've since given up on that concept because this is not where the important problem is, and it's much easier. I mean, that problem, doing things over time is much easier to solve with just saying, well, here's a state, apply a function, there's a new state. That's it.
All right. Any final pressing questions? If not, then let's thank the speaker again.
Thank you.